Hi everyone, my name is Christian and I would like to welcome you all to this event held together by StruSoft, Allplan and ESIKON, presenting the latest collaborative tool for 3D reinforcement. This presentation will be separated into three parts. First, a short introduction. Second, the workflow in theory. Third, the workflow in action. The scheduled time for this event is 45 minutes, filled with action. Our three presenters today will be Ákos Rektorist from StruSoft, Tamás Laboda from ESIKON, and myself from Allplan. A few words about me. My name is Christian Virag and I'm representing Allplan. As a product owner for automated reinforcement, I'm responsible for the development of our internal automation tools to create parametric reinforcement in concrete structures. As an engineer, I worked in the field of structural engineering for several years. My area of focus was prefabricated industrial and logistical buildings. Coming to Allplan as a previous user, my focus is to bring our automation tools closer to the user. This means that the development is driven by user requirements and needs. You might be asking, what are we going to see today? The answer is an innovative solution to speed up the workflow of structural engineers and rebar detailers for Allplan and FEMDesign users. You will see the analysis of a structure, the design of the reinforcement, and the export of reinforcement data from FEMDesign. After importing the data into Allplan, the reinforcement is interpreted as native reinforcement objects and are fully editable. Previous solutions only allow the import of reinforcement area requirements, but the creation of the surface reinforcement had to be done manually. The imported layer serves as a guide to check if the required reinforcement area is met. This workflow is only available for slabs and has severe limitations with the placement of reinforcement not in line with the major axes. In this new and innovative solution, the users can select whether they want to transfer the reinforcement data for the whole model or just selected elements. The users can also define whether to import all the reinforcement or just a selection of it. To have a fully compatible solution, all reinforcement types are supported, like straight bars, meshes, and stirrups. This tool also allows users the transfer of custom reinforcement shapes. So what are the benefits? One of the major benefits is that the whole process is fully automated and easy to use. This means that the time required to reinforcement complicated structures is reduced. The development of this tool is driven by customer feedback, and as such, it is freely available to use for all customers. Let me introduce Allplan to you in a nutshell. We are a global provider of BIM design software for the AEC industry. We address the entire design-to-build process by offering an integrated cloud technology to support federated multidisciplinary workflows. Allplan has more than 20 international locations with over 600 employees and 240,000 users worldwide, and 23 technology partners worldwide, one of which is StruSoft. Allplan provides an excellent solution for structural engineering offices with a complete support for BIM workflows to allow for a transparent and efficient collaboration between all participants, ensuring the quality of design. Let me show you an example of reinforcing the impossible. It is achieved by only using three built-in functions: the shell, with which we will establish our reinforcement depth in our model; the extract 3D curve, with which we're going to convert this reference surface into 3D polylines; and the convert match element, with which we're going to convert these polylines into reinforcement. So as you can see, we have an object which would be very, very hard to reinforce with conventional methods of reinforcing. So as you can see, it's an object with a thin wall. And as I mentioned previously, the first function we will use is the shell. With this function, I can establish parallel 3D surfaces to any 3D surface. So I select the model, I select the four outer surfaces, and after I'm done with my selection, I can edit the depth. In my case, it's 50 millimeters. And after confirming my selection, a parallel surface is made. And I can repeat the same process for the inner surface. As you can see, I am done. Again, the offset will be 50 millimeters. And after I'm happy with my setups, I can confirm it, and now I can disable or hide the original 3D body as it will no longer be needed. We have set our reference depth. The next step is to edit the UV curves in this on these surfaces. So for the vertical direction, I will set 5 UV curves, and for the horizontal direction, I will set 8 of these curves. Then the next function that we use is the extract 3D curve, with which we can extract these UV curves that we set up a while ago, and we can create 3D polylines from them. First, I select my surface and then all the 3D or the UV curves, and then I select the inner surface, and then again I also need to select all the UV curves to extract. And now we have created these polylines from that surface, so that way I can hide my surface as I got these, as you can see, these 3D lines. The third function to use is the convert match element, with which we can convert these 3D polylines or 3D curves into reinforcement. So after selecting here, you can set up some of the parameters like diameter, steel grade, and after that you confirm your selection. And I've sped up the process a little bit because it takes a while, but as you can see in the animation window, all the 3D lines, all the shapes or all the lines are converted into reinforcement. And on the object palette, you can see that we have 122 bars, but of course it's Allplan, so you can rearrange the mark numbers. And since it's a structure that has the same element multiple times, of course, we've reduced the number to 39 individual bars. And of course, you can also create schemas or full schemas, and with the created schema or in this created schema, all the reinforcement geometry is visible. You can see it on the screen. So this, of course, was just a demonstration, but imagine it's not this weird shape, but it's a hyperbolic roof structure, for example. And with this method, you will be done with your reinforcement by the time others stop scratching their heads. Thank you for your attention. My name is Christian Virak from Allplan, and our next presenter will be Ákos from StruSoft.
Thank you, Christian. Hi, my name is Ákos Rektoris. I'm a product manager at StruSoft and responsible for the interoperability development of FEMDesign, including the topic presented today. I'm a structural engineer by profession, and I have been working for more than 20 years in the development and improvement of BIM-based collaborations between design disciplines, 12 years at Graphisoft and 11 years at StruSoft. Allow me to briefly introduce our company, StruSoft, where I have more than 240 colleagues in 19 international offices, mainly in Europe. The name of our company indicates that we are developing several design software for structural engineers. Among them, the most prominent and popular one is FEMDesign structural analysis software, whose main functions are structural 3D modeling, design, check, and documentation of structural elements and systems, and thanks to its own drawing tools, even CAD-level drawing. FEMDesign is an analysis software for linear and nonlinear tasks, statics, and dynamics. With the exception of aluminium, we can design structures for more materials and according to Eurocode national annexes. The interface and design tools of FEMDesign enable detailed examination of small, medium, large, very complex projects, or just one single object. With the help of FEMDesign, in addition to building structures, any other structural artifacts, including, for example, bridges, can be designed and checked. An extremely important and innovative solution within FEMDesign is the modeling and examination of the joint effect of the superstructure and the soil modeled with nonlinear 3D volume model. During the development of FEMDesign, we always put a lot of emphasis on providing the most efficient and modern solution for the tasks and requests of our users. An easy to learn, stable, and reliable working tool. Thanks to our strengths, we have more than 20,000 users in many countries, and we are proud to be the market leader in Scandinavia. The BIM-based collaborations integrated into FEMDesign ensure effective participation in design workflows. with applications of modeling, algorithmic design, detailing, and data management. Like Allplan, we are open BIM fans and supporters, and FEMDesign supports many open standard-based and direct software-specific connections. And this brings us to today's topic, the FEMDesign Allplan collaboration. First, let me give you a brief overview of the workflow and steps of the connection. The initial structural model can come from any BIM modeling software, thanks to IFC, SCF, or direct connections, or from parametric modelers such as Grasshopper and Dynamo, or from external programming or database, or they can be created with FEMDesign's modeling tools from scratch and based on CAD drawings. In this example, the initial model was converted quickly from a concrete formwork model, created and exported with Allplan. We can then build the final analytical model by setting the final position of the objects, like eccentricities, the concrete materials with physical properties, like tight-dependent parameters, and by adding the supports, the connections, the loads, and the load combinations. FEMDesign enables us to design and check concrete objects by modeling and considering their realistic behavior, like cracking, shrinkage, creep, elasticity, post-tensioning, and fire resistance. Optimization-based auto design or just check for applied parameters can be applied for shells like walls, slabs, roofs. Several design options can be considered during the optimization process for surface reinforcement, including base net, secondary rebars, shear, and punching reinforcement. For example, for surface reinforcement, we can specify the set of available rebar diameters with a fixed spacing value, or we can fix the applied bar diameters and set intervals for spacing. Both optimization and check are based on utilization calculations. Similar detailed design can be done for bar elements too, for columns, beams, concealed beams, and strip foundations. Following automatic design, we also have the opportunity to manually modify and fine-tune the parameters and distribution of the applied reinforcement, in addition to a very fast parallel utilization check. Elements having certain common properties can be assigned to a design group, and so its members will be designed in the same way. For example, uniform reinforcement will be calculated and considered for all bars within one design group. The end results and outcome of the design are real applied reinforcement objects with parametric 3D geometry for the examined concrete structural elements. So, surface and bar reinforcement, surface shear reinforcement, reinforcement in footings, and punching reinforcement. And these reinforcement objects, so all types that can be designed with FEMDesign, can be quickly transferred, merged into Allplan projects with just a simple click on Export to Allplan. The import can be done very easily with the free add-on, so-called Python part, developed for Allplan, and by specifying only a few import options in a single dialog box. These setting options drive some very useful and effective automatic operations, like automatic bar numbering, management of bar anchorages, rebar steel grade mapping between FEMDesign and Allplan, automatic hook assignment to stirrups, automatic slicing and overlapping of area reinforcement, importing of all area rebars or just the secondary ones without the base nets, and with the last option, we can match the drawing files of the host Allplan project with the imported reinforcement by types, options, and/or directions. According to the settings, as a result, real Allplan type reinforcement objects are created and merged into the project from which the import was started. Here we can see them in different 2D and 3D views. In other words, the reinforcement calculated and designed in FEMDesign can be used as parametric editable objects within Allplan. Thus, for example, we can change the position and distribution, supplement them with hooks, list them in detail, and label them according to unique rules. With the standard editing tools of Allplan, we can quickly produce the final status of detailed reinforcement documents and reports. For example, for the top reinforcement of slabs of one building story, or the complete reinforcement of walls, or the complete reinforcement of columns. Now let's see the connection workflow live in practice, presented by one of our common users, the company ESIKON, who uses FEMDesign and Allplan together on a daily basis. Tamás, please continue with your presentation.
Thank you very much, Ákos. Welcome everybody. My name is Tamás Laboda, and I'm a structural designer working at ESIKON Ltd. After a short introduction, I will show you in a live demo the revolutionary structural design method that Christian and Ákos have explained in theory. Our company, ESIKON Ltd, is a medium-sized structural designer team with 15 engineers in 2 offices located in Eger and Budapest, Hungary. We practice static design as general structural designer and also make workshop drawings for the biggest Hungarian prefabricated concrete factories. We mainly design concrete structures, but we aren't afraid of designing steel or wood structures too. On our reference list, you can find office buildings such as the ESIKON Research Center located in Budapest on the riverside of Danube, the Budapest one with its wavy facade forming a 4-leaf clover floor plan, or the Dürer Park Office 2, which is a reconstruction work of a monastery built in the end of 18th century with floor extensions and a new building part. On the list, you can also find residential buildings, mostly located in Budapest. My special favorite is the Kassák residence, which has thick load divider slab, which transfers loads of the upper columns located in the apartment partition walls in a hectic order layout to the columns located at the parking story with a strict order layout. On our list can be found several industrial buildings with various sizes, such as production halls and logistics centers. For example, the Central European Logistics Center of Jusk, located in Eger, with approximately 150,000 square meter net floor area. In our practice, we use FEMDesign for 3D finite element modeling combined with 2D models to calculate the inner forces and displacements of the elements and to analyze the structural behavior during seismic action. We also use this software to calculate sufficient reinforcement and to check the utilization of steel structures. We make our 3D geometrical model in Allplan based on beam requirements for the easier communication and workflow with the other designer teams. We also prepare our drawings with the help of Allplan, layouts, formwork drawings, reinforcing plans with details. We are working in team on the same model, which we can share over network with the help of Allplan. In the first half of the demo, I will prepare the simplified finite element model of an office building with all the loads and effects to do the calculations of the structural behavior. Then I will demonstrate how to determine the sufficient reinforcement for the different type of concrete elements. In the second half of the demo, I will convert the reinforcement data from FEMDesign to Allplan for editing and detailing in order to create the drawings of the structure. As an example, I have chosen one of our successful projects, the Nordic Light Offices Trio building, located in Budapest at Váci Street. This is a 5-story superstructure building with further 2 stories in the substructure. It has reinforced concrete structure with columns, flat slabs, stairwell and elevator core made of concrete walls and also some retaining walls. So let's begin with the FEM model. As a first step, you have to prepare the geometrical model. In FEMDesign, you have several possible ways to create the structure. First, you can draw the structural elements by hand, which is very easy thanks to the CAD-based system in FEMDesign. You can edit the elements in no time, as you can see it here. So the software is perfect for every phase of the design, from conceptual design through permit design to detailed construction design. You can draw the structural elements by hand with just a few clicks, and you can create beams, columns, slabs very easily. On the other hand, if the architectural designers have 3D model in IFC format, you can use this as a reference for your model thanks to the two-way IFC connection. During the IFC import, FEMDesign can convert the geometrical model into analytical model to create a base geometry with all the stories, as you can see here, and all the required attributes like cross-sections for the load-bearing structures, and also some load-transferring elements like covers. As you can see, in a few clicks, I was able to create the whole analytical model of the building instead of long hours of editing. This model yet contains some discontinuity, which I can adjust with a very useful wizard in FEMDesign, adjust analytical model. As you can see, with a few clicks, I can align all the slabs to the stories and do the same thing with the beams, and also I can adjust the base slab to the foundation level. You have the ability to modify the elements one by one. For example, for the bar elements, I can change the cross section if I want. I can change the material, and I can also set some hinge beam edge ends for the beam, and also some eccentricity here. As you can see, everything changes in the model. As a final step, we must determine the supports. Thankfully, the base slab of the building was modeled in a proper way, so first support was automatically added to the model, and we only have to adjust the springs of the supports here. Our geometrical model is finished now, so let's move on to load model. Starting with the load combinations, we can make them manually. As you can see, the dead load is calculated automatically by the program, or you can save your favorites and load them at any time you want. I do the same now, so that now appears all our load cases. Moving on to floor finishing layers. These are surface loads with 2.5 kilonewton per square meter. And the good thing is that we can assign these loads to the structure. For example, I will assign these to the slabs. That's good because if the boundary of the slab changes, for example, I will take a little opening here, all the loads and the boundary of the loads will be aligned to the new structural boundary. In FEMDesign, for applying meteorological loads, such as snow load or wind load, we can use wizards. For that, we must create climate load panels to make the loads act as surface loads. Or for wind load, you have an option to act them directly to the edges of the slab by clicking to the appropriate places of the wizard, and the wind loads will be created conforming the Eurocode standards with all the necessary load cases. Moving on to load groups, you can make them automatically, but now I will load my favorites here too. As you can see, there are some dead loads, live loads, the snow and wind loads, and also some seismic action, which I can set up over here. I have to set up the behavior factor, the peak ground acceleration, and the soil parameters here. So everything is done with the load model now. As a final step before calculation, we have to generate the finite element mesh, which is very fast thanks to the FEMDesign, and FEMDesign can also automatically calculate the necessary finite element mesh size. Moving on to analysis. First, you have to calculate the eigenfrequencies and eigenshapes because we have seismic effects here. Then as a second part, we can run the calculation of load cases, load combinations, and the seismic calculation according to model response spectrum analysis. We are short in time now, so I have already prepared a calculated model for you, which you can see on my screen now. First, we have to do some checks, such as we have to check the vertical displacements. As you can see, there are no flying elements here, no huge displacements. We haven't got any local discrepancies, and the deflections of the slab are good. So the model seems to be okay from this side. Another effective check is to keep an eye on the reaction forces. We have a thick base slab here, so the surface reactions are well balanced. We don't have any zero reaction forces, so we can say our model acts in a proper way. After running structural analysis, we go further with the design of reinforced concrete elements. We have 4 different options: design of bar elements such as beams or columns, the bending and normal force design of surface elements like plates or walls, the shear and punching design of surface elements, and finally the design of concealed bar elements in shells. I will begin with the bar type elements. As a first step, we have to configure the reinforcement parameters here. You have to set the allowable crack width. You have to check if you want to calculate the elements as columns or not. And you have to set the eccentricities taken into account. On the next tab, you have to set the fire duration, and you can modify the boundaries of the element in case of fire. For designing, you have 3 different options. 2 manual options with fully manual drawing and taking the reinforcement as a parametric reinforcement, or you can choose automatic design in FEMDesign, for which you can set the parameters such as the cross section if you want to make it different as in the model. You have to set the diameter of stirrups and the diameter of longitudinal bars. You have to set the cover, and you can make FEMDesign design uni or biaxial reinforcement, symmetrical reinforcement, which is very useful by designing columns FEMDesign. By clicking on the red exclamation mark, you can select the elements you would like to design here, and in this utilization tab, you can find all the elements or the element groups if you have such a thing, and all the utilization of these elements here. Moving on to shell elements, we have to start with the calculation parameters here too. Here we have to set everything by the fire tab as in bar type elements. And on the general tab, you have to set for the bottom and top reinforcement the diameters of the rebars and the concrete coverage, and also the allowable crack width. By auto design, you have to prepare some of the parameters like on the bottom and top face respectively, if you want to have a base net and the diameter and the spacing of that. And for the additional reinforcement, you have 2 options: to make it with fixed base and varying diameters, or on the opposite way. Usually I use the first one, so I will continue with that now. And by clicking on the red exclamation mark, you can let FEMDesign design all the slabs here. You can use this mode to reinforce all the walls, but my special favorite is the concealed bar reinforcement, which is perfect for walls. If you make column-like and bar-like elements to the edges and to the sides of the openings, FEMDesign will convert the surface internal forces into bar-like internal forces. So the big internal forces will be handled with these bar-type elements. You can set all the parameters like bar elements, and as a result, you will get reinforcement like columns and beams here. It's good because after that you will don't have to make additional U-shaped bars to the edges, and by the reinforcement you will only have to make some base mesh to the middle of the wall here. For shear reinforcement and punching reinforcement, you have several possible ways in FEMDesign. For example, you can make this with strut rails, bandage rebars, or circular stirrups here. Okay, I have prepared you a fully designed model for you, so I can show you that all the bars and reinforcement are in the elements here. We have the columns, we have the reinforcement of the beams, the concealed bars with the mesh in the middle of the wall, and all the base mesh and additional reinforcement appears in the slabs too. If you have to make some documentation, you can do it easily in documentation module. We are able to save forms here, so later with some clicks, FEMDesign will automatically generate you the whole documentation with all the pictures, the text, and all the diagrams with numbering and numerical results automatically. The main advantage of FEMDesign is that the picture in the documentation is not a static picture. It's a view of the model, so anytime it can be moved, it refreshes automatically and can be changed at any time. We can also put detailed calculations to the documentation with Eurocode calculation formulas and utilization graphs too. Now we have a finished finite element model with all the structural design and reinforcement calculation. So we have to convert the FEMDesign reinforcement now to Allplan reinforcement. For that, we choose File menu, Export to Allplan, and we have to select the elements we would like to export to Allplan. Now I choose columns on the second floor, and we'll save it here. And as a next step, I will export the slab above the second floor. Okay, everything is done in FEMDesign, so we can change to Allplan program. In Allplan, we have to prepare the building structure with all the stories, as you can see it here, and all the related drawing files for the geometry, also for the reinforcement, and maybe you can prepare the view files here too. We have to create the geometrical model with architectural elements here, and as I have said, you can prepare the formwork drawings without reinforcement now. So let's import the reinforcement here. For that, we can find it in the library under default Python parts and FEMDesign reinforced concrete. By double-clicking on the icon, it starts. You have to select the file that you would like to import. So I will import now the slab reinforcement. Clicking on read file, you have to determine some parameters. For example, the starting label ID for the bars, the hook length of the stirrups, overlapping factor, maximum bar length, and you can also add some additional overhanging bar anchorages if you want, or you can select if you want to import the reinforcement with or without the base mesh. You have to set the material, and of course you have to say on which drawing file do you want the reinforcement to be landed. It can be different drawing file for the bottom, the top, and the X and Y direction too. By clicking on execute, the import will be done. So let's see what we have done. I will show you that what the columns are looking like after importing. As you can see, all the stirrups, the longitudinal bars are in the columns now. So I will show you what it looks like in the sections and views of the model. This is the row reinforcement in the columns. As you can see, these are fully editable native elements. So I can elongate the longitudinal bars. I can change the diameter of the stirrups. I'm able to change the spacing of the stirrups or the length of the placement here. And also I'm able to change the hook length of the elements. For example, here I will change it the angle of the hook and the length of it here. So these are fully editable elements in Allplan. And after some labeling, giving some dimensions and the bar schedule, of course, you will have a perfect finished column reinforcement drawing. I will show you another example for the slabs, for the slab top reinforcement, where the native reinforcement looks like this. I have only imported just the additional reinforcement and not the base mesh. And after some labeling, you can get this drawing, which is also fully editable. As you can see, you can change the display mode of the rebars to show all the rebars, just the middle one, or the selected one that you would like to see on the plane. As a final step in layout editor, you have to place the drawing files to the canvas, give them some other text and infos, and you will, as you can see, in a few minutes, we can create perfect reinforcement drawing in Allplan with the help of FEMDesign. Thank you for your attention. You were listening to Tamás Lapoda from ESIKON Ltd. And now I give back the floor to Ákos.
Thank you, Tamás, for your impressive presentation. Everything we presented today was recorded and will be sent to you in a follow-up email. You can try the connection and full functionalities with full-feature trial versions of FEMDesign and Allplan, which can be requested free of charge and without conditions. The Allplan add-on required for the connection can be downloaded for free from the StruSoft FEMDesign website. Since we are getting close to the end of the webinar, unfortunately we don't have time for live question and answer session. But of course, we are happy to answer any questions you may have or to help you with problems arising in your projects and tasks. Please contact us through the email address you can read here on the slide. Thank you again. Thank you very much for attending this presentation, and we hope you found it interesting and useful. Thank you. Goodbye.